name is Brian Griffin. I went to school at Iowa State University, and I work at NASA Armstrong as an operations engineer. Moving out to the desert from Iowa was a huge shock in terms of geographic location and the environment. And 7 years later, I'm still trying to get used to brown as opposed to green. But at the same time, I just remind myself where I get to go work every day. At Armstrong, our purpose is to fly airplanes for flight research and collect data. The operations engineer is responsible for helping to coordinate all the efforts required to both integrate the research experiment and then flight test that research experiment to fulfill that mission. We interface on a daily basis with the chief engineers, the project managers, the ground crew, even our center management, in order to integrate whatever that particular research mission is onto the airframe, do it safely, and then fly it safely and collect the data required. We'll collect all types of data, pressure data, air data from the aircraft, visible and infrared images of flight test fixtures that are underneath the aircraft in support of analyzing supersonic airflow over these fixtures. The project I'm currently working on, the F-15 high-speed aircraft, the research that it's supporting is hopefully at one point in time going to allow a supersonic flight commercially over the U.S. and throughout the world, and I think the ability to have at least some type of impact in that is a very rewarding experience. A typical flight test mission starts much earlier than the day of the mission. For example, all the coordination and scheduling required to get the airspaces and the aircraft in our system so everyone's on the same page and aware that the flight test is going to be performed.
Good morning, this is crew brief for SBLT2 flight number 2.
On the flight day, we typically have crew briefs where we brief what the mission is for that day. We discuss the flight cards, what the flight cards and the test points are going to be on that mission.
The objectives are to determine the stability of the boundary layer and the extended laminar flow for the test article surface. This chart here shows the flight envelope that we have cleared for this series of flights. Failure of any of our safety of flight parameters is an immediate cancellation and RTB.
All right, we'll see you out there in a little bit.
After the brief, we'll staff the control room, get the control room screens all up and running. We'll do day of flight checks on the ground, which is ensuring that the aircraft is ready to go before we take off. And then the flight mission itself will take off, perform the flight cards as briefed.
NASA 36, NASA 1. Good. Yeah, we're ready for card 5, the wing rock, and turning the camera to standby when able. There's your wing rock. Copy.
My role in the control room as ops engineer on the F-15 project is to serve as the mission controller. So we are the interface between the control room personnel and the pilot flying the airplane. Typical communication that goes back and forth between the controller and the pilot is just verifying what flight card we're on, what test point we're on, what the next maneuver might be, if there's any information that the principal investigators are looking for, or any information from anyone else in the control room that needs to be relayed to the pilot. We'll be letting them know about that. We'll let the pilot know about how much fuel he still has on board, airspace checks if he's getting close to boundaries and he needs to make turns. Just any information that can increase the situational awareness for the pilot and also help the pilot perform the mission, complete the test cards, and then come back and land.
Mission controllers, this is flight on data 1. We're ready for the supersonic run.
Copy. NASA 836, NASA 1 is ready for the run, and I have you right now at 48.5 for reference. 1.83, 4, 5, hold.
There is a lot of pressure associated with being the mission controller, the only person talking to the pilot. That pressure seems to decrease with experience the more flights you perform.
Board NASA 836 flight, like to RTP straight in. NASA 836 registered, runway 4 right approved, wind 320 at 9er, altimeter 3009er.
3009er, and we'll start our descent.
Being the guy on the ground talking to the pilot and doing that communication with the rest of the control room is a rewarding experience. When you come back and capture the data that you wanted to capture and everyone is happy with the flight, you're going to have a lot of success, but sometimes you're going to have failures. And the important aspect is to not just learn from the success, but also learn from the failures. Being able to have the chance to fly in these high-performance aircraft in the backseat and perform mission duties is also a rewarding experience in itself, let alone the ability to just fly in a fighter jet. Flight test engineer sits in the back seat, responsible for flipping switches, monitoring data, and communicating to the pilot and also to the ground during the research flight to make sure that the mission is being accomplished. Flying past Mach 1 is definitely an excitement, but you don't necessarily feel that you're going past Mach 1 until you start to slow back down. When you slow back down, you can definitely feel the deceleration. It's very pronounced. Getting used to the motion sickness is definitely always a challenge, but I think the benefits of being able to fly outweigh those challenges. Every day in OE is typically different than the day before and the day upcoming. As an ops engineer, the overall picture is to ensure the mission success while also ensuring that the integrity of the airframe is safe and the airplane itself is airworthy. The chance to come to work every day and work on these things and be involved in this flight research to help put those pieces together to fulfill the mission is a very valuable experience.